Recording. Alright, I sure hope it's recording. I can't see because of the Zoom window. There it goes. Alright, so today, Pong and Python. Are you ready? So we are finally, what we did before was we got the ball in a weird spot, random direction moving all around. We got the paddle moving up and down. All that's left is to hook them together. That is very exciting. And by the way, wink wink, this is going to be your last programming assignment. You're going to take everything that I did today and just re-implement it. All right. So my gift to you as your last programming assignment is just follow along, do this, and turn it in pretty much. You can add cool stuff if you'd like to, but what I do today is going to be your last programming assignment, and I will therefore not be giving you any of the files that I write today. You're going to have to watch the video. All right. If you want to do it all over again, or just follow along now. So that is my plan, my gift to you. You're welcome. But let's get started. Let's make Pong in Python. We're ready. So yeah, so we got a lot of things to do, but we did most of them. We have so many things. We made sure that the paddle didn't go out of bounds when it hit the top or the bottom wall. We had an if statement to check for that. Let's go back to all the code that we wrote before and talk about it. Let's see here. So I need to make a new file called like pong.py, and I'll put it on my desktop. Because you don't get it. I will not be giving you this file, but I will be writing it, and you can see it as I write it. But I do want to look at all the stuff that we talked about before. So we had the paddle program and the 2D bounce program. Let's bring those two back up, because we'll need to look at them. We'll need to add them. Whee! So here's the 2D bounce program. It made the turtle a very stretched out square, and oh sorry, this is the paddle program. Turtle is a very stretched out square. That makes him a paddle. And we hooked into the up and down key press events, we say, and made every time we press the up arrow, for example, call this go up function. That's what the turtle was listening for and doing for us. And then we made sure to not like make him go out of the bounds, because that would have been bad. So we had our little bounding square, and we had to figure out what in the world do we do to make sure the paddle stays within the range. What do we have? We had, this was the y equals 200 line. We had to worry about the size of this paddle, and it's always relative to its center, and so it was 120 high, and we wanted it to go up a little bit, down a little bit, but the farthest up it could go is like right here. And what was that in terms of the highest y coordinate the paddle could ever have? It was, well, it's not the 200 exactly. That would be the paddle's like in the middle here. It's 200 minus this half of its height, so 60. And so the highest as far as y could go for this paddle is 140, and that's what we watched for. That's why we did this right here. If paddle y is greater than or equal to 140, set it to 140. If you went any farther, bring it back, and don't let it be any bigger than that when you're going up. All right? And similar for going down, you don't want to go more than, this was y equals negative 200. You don't want to go any farther down than negative 200 plus 60, so like negative 140. And so that's what we were watching for, and it led to this. It was wonderful. Yay. So that was the paddle, and that was nice. So that was working just fine for us. This can be the start of our Pong program. Why not? I'll copy and paste this into our pong.py, and so now we have essentially paddle all over again here. So this is the start of pong.py. Whee! So what do we have to do now? We have to introduce the ball. That was the other program. That was this program over here that did the 2D bouncing. Again, we already have the bounding square. That's all fine. but we needed to make the turtle a square, a perfect square, and like set up some random starting points and directions, bounce if hit wall, etc., draw frame. All that stuff needed to be there. And this was that program, remember it. Oh, I almost hit the corner, nice. And so that was our game. Or that was our 2D bouncing game, at least. And so we need to bring this also into our current program, which just looks like the paddle right now. Does anybody see a potential issue? This is the paddle program. What was I doing in the 2D bounce program that I'm already doing in the paddle program? Does anybody see it? It's a bit of a problem. I think I'll need the turtle library open as well. But the turtle is the paddle, right? This is the problem. The turtle is the paddle right now in our current version, but the turtle also needs to be the ball. We need a ball on the screen as well, and we made sure that the turtle did that too. What? The secret is we can have multiple turtles in our program. That's what we need. We need a turtle to be the paddle and a turtle to be the ball, and give each of them separate directions on where to be. Does that make sense? You can't like have them like be the same thing. That wouldn't work. So we can have multiple turtles, and what we've been doing all this time is being like turtle.goto, turtle.forward. That moves what's called the default turtle. You get one turtle when you use the turtle library by default. If you want another turtle, you have to make one as a variable. They go in variables, and you say turtle.capital turtle. That's a function that gives back a brand new turtle, and you can assign that into a variable. And so that's what we're going to do. We're going to make a paddle turtle and a ball turtle, and instead of saying like turtle.goto, when we want to move the paddle, we're going to have to say paddle.goto. We're giving a new name to the turtle that gets to be the paddle. So we're going to have a bunch of turtles on the same window now. All right? So that's going to be our first change. So this is all fine. Draw the rectangle. The default turtle can draw the rectangle, but we need to make a paddle turtle. Make a turtle for the paddle. And so that means we need to make a new variable called paddle and set that equal to a brand new turtle, turtle.capital turtle. All right. And that one's going to be square and pink and stretched like this. And so it's not the default turtle that we're messing with now. It's this new turtle that we're calling paddle. And so everywhere I said turtle dot, it needs to be paddle dot. Paddle up, paddle go to, etc., etc. Paddle go to, because this is supposed to move the paddle. Paddle go to, all that fun stuff. So that's what needs to change. The default turtle can still listen for the key presses and draw the rectangle and all that. That's all fine. So I'm still saying turtle.onKeyPress, do all that stuff, but it's messing with the paddle turtle when it gets those functions called. You see that? So that's what's going on, and that's kind of how you do this. The default turtle can also draw the rectangle. That's cool. That is okay. Let's see how that works, because I've just really made a new paddle variable and changed it to paddle dot everywhere. Does that do most of what I want? Let's see. No, it does not. So let's see here. First of all, the default turtle is still visible because we did not change it into the paddle. That's one thing. Second of all, I'm pressing up and down. The paddle is sideways now. And the reason it was sideways is because by default, every brand new turtle, when it starts its life, it's facing east. We made this default turtle the paddle, and it was facing up and down. That's what allowed it to be in the right orientation. So I can re-stretch this paddle. That's fine. Or I can just make it face up, and then the current stretching will work. So either way works. So let's fix that. Which is kind of funny. So just to keep it all the same, this default turtle, when we finished drawing the rectangle, it was facing up, and that's why we stretched it in the way we stretched it. But this other one is looking a little weird. So if I just say paddle dot set heading to be 90, that's facing straight up, then it will work exactly like the default turtle. Because by default, it's facing east. There it goes. And so now we have a normal paddle, but we also have the turtle, the default turtle just chilling there. You are able to hide the default turtle if you would like, but everything else seems to work. So let's learn how to hide the default turtle. I think it's just called hide turtle. Yeah, turtle.hide turtle makes a turtle disappear. And so we can say after we're done drawing the bounding square, which is all that the default turtle is supposed to do, we can hide the turtle. So we don't see it in the corner there. So that's the default turtle, still turtle.hide turtle. There we go. And then now, after it's done drawing that bounding rectangle, it will hide itself. And now we just have to paddle. All right. So that was a lot to worry about. It's kind of funny, but that's a good start. Are there any questions about how we got to this state? Now there's two turtles in the program, one to draw the rectangle and listen for key presses, and then one to be the paddle and move up and down. Now we have to bring in the ball into the equation. So that is going to require some things. So let's see here. Where is that program? We have it's the 2D bounce program, and what do I want? We have the draw rectangle, that's already happening. Now we need to essentially include all of this stuff. So this was, I don't know, this was paddle stuff. And then down here maybe can be ball stuff. And I'll take all the ball stuff, which was make that square ball, set random spots for it and directions for it, go to a good starting point, bounce if you hit the wall, and then draw a frame repeatedly. So all that's all the ball stuff. So let's bring that in. And so again, this original ball stuff is messing with the default turtle. We would like a separate turtle to be the ball. So I'll be like, make a turtle for the square, or for the ball, let's say. So I need to say turtle.capital turtle, call it like a function, to make a brand new turtle, and I'll call it ball. And so now instead of saying turtle.shape, I'll say ball.shape, ball.goto, when I'm messing with that particular turtle. All right, so these are just normal variables, turtle y, whatever. I could technically call this ball x offset, but we'll just keep it like this. This is fine. And then it's ball.goto. Let's see was that everything? Any other uses of the default? There it is. Ball.goto. I think that did it. Let's see. That's just all the ball stuff. All the paddle stuff is fine. Draw the bounding rectangle with the default turtle. Paddle stuff, so make a new turtle for the paddle. Set up the functions and the listening and the key presses. And then ball stuff, dealing with this ball turtle. Let's see if I get any errors now. Oh, cool. We didn't see that start. Let me do that all over again. We're drawing the bounding square. Got a paddle, got a ball. The ball is bouncing properly. It looks like, yeah, I didn't mess anything up. Cross our fingers. And I can still press things and get movement. Yay. Awesome. So, obviously, the last piece of the puzzle is going to be bounce off, because that's not what's happening right now. But it looks like it's all coming together. Any questions about how I got it to be what it is so far? All right, let's see here. I need a few things to. Okay, let's change the color of one of these. I don't know. They can both be pink if we want them to be pink, but I don't know. What color should? Maybe we can change the color of the paddle or something. Maybe this one can be red. It's the fill color that changes the color of the thing. Is that a nice? I don't know. It's good enough. But that could be our game. What's the opposite color to red? Would have been green, I guess. Pink. I don't know. We'll deal with colors later, I guess. But that's a good start. What is there left to do? So, one thing, I guess, that we could do is when we start this program, the ball is going to a random spot. So, like, random spot between negative 150 for the x and negative 150 and 150 for the y. That would mean that sometimes, if you get very unlucky, like the ball starts out moving to the left, way down here, something like, or up here, nowhere near the paddle. And so, like, you immediately lose. So you had no chance if the ball starts out right next to the corner and moving left. So let's make it so that that never happens. Let's make it so that the ball always starts on the right half of the screen. Okay? And so all that means is when we start the ball's life, just make sure it's got like a positive x value. The y can be anything. Just give it a positive x value so that it never like starts its life right here and just immediately ends the game. Does that make sense? So let's do that. Let's start the ball on between like 0 and positive 150. So always on the right. Right half of the screen. That should do it. And so now no matter what the ball, even if it wants to move left originally, there's time for us to get over to it, which is nice. Okay, so now it's going to be random, could be any direction, but its initial x value is going to be always 0 or greater, and so there's always time for us to move our paddle to. Okay, that was a simple change right there. Let's see what else. Oh, yeah, we need a way to lose the game. If the ball really does eventually get to the left side and we missed it, then the game should stop. So the ball should never bounce off of, then, the left wall. That should not work anymore. The game should end when the ball hits the left wall. Does that make sense? So if the ball ever hits the left wall, like, it should be game over. That's kind of how we should play this game. So what we can do is this. We can keep track of whether the game is over or not. And so originally the game is not over. Yes? So what do I want to call this? Is game over? Sure. So is game over could be a variable at the very beginning of our program. And we'll set it, of course, to false. Yeah? Because the game is not over once it starts. It's only over if the ball hits the left wall. And we would like to continue moving the ball, like have the game still be in play, as long as the game is not over. So while it's not true that the game is over. So while not is game over, draw a new frame. Does that logic make sense? Any questions about that? And it's this variable that we're going to be messing with if the game ever ends. We'll set it to true, and that will stop this loop, and there will be no more playing possible. The user will have to restart the game. So I think that's how I want to do it. So now we have to hook into when the ball hits the left wall. If the ball hits the left wall, do not bounce off, end the game. And so that was in the bounce of hit wall function. It was this one. If the x ever gets this small, that means we either hit the left wall or try to go outside of it. We want to, instead of like bring the turtle back inside, change the x offset, you can bring the turtle back inside, that's fine. But we would like to end the game. End the game. Since the ball hit the left wall. The user lost. So is game over. If we ever hit the left wall, should be set to true. Don't even try to bounce off. There's no need to deal with offsets or anything. Just stop the game. Is game over, set that to true. And I am messing with a global variable inside of a function, so I have to say it. I have to tell Python that I'm doing that. So is game over is a global thing that I'm going to check and change potentially. So that's pretty much the only change. Is game over at the very beginning, set it to false, and then repeatedly, eventually, it will become true. So while not is game over, so while it is game over is not true, keep going. And then the second it does become true, not of true becomes false, which will stop this loop. And that will be caused by that line. And so, well, there's no collision checking, but let's pretend that I missed the ball. We're going to get to this if statement. Yay. We're going to get to this if statement, and it will notice that we hit the left wall. It will set is game over to true, so that the next time it comes into this loop, it will be like, while not is game over, but is game over is now true. So while not true, not of true is false. And so it's like while false, and a false condition stops the loop. All right. And so that's why this happened. The ball is no longer moving. I guess the paddle is still allowed to move. That's fine. But the game is over. You have to exit out of it and try again. All right. Are there any questions about the logic behind any of that? How this will stop the game? This is our draw a new frame loop. We want to stop drawing the ball in a new spot, moving the ball around whenever the game ends. And we'll use this variable to keep track of when the game is over and set it when we lose. Because that's pretty much most of it. Because the last thing now, the last piece of this puzzle is bouncing off. This is very slow, but I might be here with the paddle, and it should have bounced off, but it didn't, and so I'm just always going to lose the game right now. We need to bounce off the paddle. That is the last thing to do. Okay, so we want the ball to bounce off the right side of the paddle, and to make this easier on us, just like we were doing bounce if hit wall, let's do a bounce if hit paddle function. So if we hit the paddle bounce off, bounce if hit paddle. And so that is going to be how we keep track of that. All right. So we'll make another function that deals with comparing our paddle x and paddle y to our turtle x and turtle y, because that's the ball. Maybe I should be calling this ball x and ball y. I'll do that. It will be a little tedious, but I think it's worth it. Because it's not just a turtle anymore, it really is the ball. Because I'm going to be comparing it to the paddle's x and paddle y, and it's the ball that we're comparing to the paddle. So let's change all this. I think that would make me feel better. And then I'll search to see if I messed anything up and missed anything. Ball y offset. Ball x. Ball x. I'm sure there's a find and replace in idle that I could be using right now, but that's okay. It's more obvious when I do it this way anyway. Ball x offset. Ball x, ball y. And now let's see how much I forgot. So turtle underscore find next. Okay, sure, we can use ball width. Do I ever say that anywhere? No clue. Go to ball x, ball y. I think that was all of them. So let's see if it still works. Changed all those variables. No. Alright, what do we do? Oh, that's because the bounce if hit paddle function does not yet exist. Well, let me comment that out just quickly to make sure that everything else still works. Oh yeah. Okay, good. And the ball still bounces. Okay, cool. So now we can deal with the bounce if hit paddle function. That makes me happier. So, all right, the ball has a spot where it is right now. It's like somewhere in the middle. It's like here's the ball's XY, and then here's the paddle's XY. we want to compare them, and if something is true, we'll know that we've hit each other. The paddle has hit the ball or vice versa. So we're going to be comparing ball X and ball Y to paddle X and paddle Y. That's why I went and changed all those variables. That's important. So, all right. We're going to make a bounce if hit paddle function. If hit paddle. And so this is meant to change like where the ball is. And let's see here. We'll figure out what we need to put here in just a second. But this is going to handle noticing when we've hit the paddle and we should bounce off of it. Okay? So that is our goal. And so now the hard part is, what in the world do we check to see whether the ball has hit the paddle? How do we know when that's true? What do we have at our disposal? We've got a ball X and a ball Y and a paddle X and a paddle Y. So let's draw all the things that we know and that we have, and let's try to understand when it should be true that the ball has hit the paddle. So here's the paddle. It is relative to its center, its coordinates. So this is paddle X, paddle Y. It tells us where that center is. And it was always a 30 by 120 paddle, the way that we stretched it. Okay. And so the ball has hit the paddle when it's like right here or something. And it's moving to the left as well. The ball has hit the paddle if like these touch ever, or the ball tries to go even farther to the left than that. But what does that mean about the ball? It's saying something like, I guess this is fine. It's like right here. What does this mean about the ball when it's right there? So the ball is now relative to its center. It's got, I don't know, this is ball X and ball Y now. And the ball was stretched 2 times on each axis. So the ball is 40 by 40. Okay, so the ball has hit the paddle when, like they can't be exactly touching, these X and Y coordinates can't be perfectly on each other, but the distance between the center of the paddle and the center of the ball is going to be half of this width, right? This is 15. And then half of this width, which is 20. You see that? So if their centers are ever this far apart, then they're, at least as far as the X is concerned, they're pretty much touching. You see that? That's important. That's going to be the important part. So they're touching if their X's are within this range. So let's talk about that. The paddle. The ball touches the paddle when. All right. This is true about their X's. They must be like right here, any smaller than that. The distance is this much or smaller, so like 15 plus 20. The distance between their X's. So like ball's X is either right here, it's either equal to this or less than it. It's either equal to or less than paddle's X plus 15 plus 20. Plus 15 plus 20. So that's one way to notice that they're like, as far as X is concerned, they're right next to each other. Does that make sense? The ball is, at least as far as the X direction is concerned, the ball is touching the paddle when its X is either, like relative to the paddle, the ball's X is equal to 20 plus 15 plus the ball, plus the paddle's X. So it's like exactly this far away. Or if it's any smaller, like we've somehow managed to squeeze the ball in between the paddle somehow. That would be an even smaller X for the ball. So that's That's one thing. Do we want to bounce off every time this is true, though? If you think about it, the answer is no, because like, what if the ball's down here, not anywhere near the paddle? This will still be true, right? The x and the center of the paddle is still within that range, but we don't want to bounce off the ball if it's not here. So we also have to consider the y coordinates. You see that? So otherwise you'll bounce it off even when it's nowhere near the paddle. So now we have to think about, all right, what is the highest and lowest spot on the paddle where we would like the ball to bounce off? And I think if you think about it long enough, it would be like this. Let's say that you could make two decisions here. You can be like, this is the last time the ball bounces off the paddle when it's like this, or you could be nice to the user and say, this is the last time the ball will bounce off the paddle when it's up here. See that? So that is, both of those are possibilities. Let's be nice to the user and say that this is the last time the ball will bounce off the paddle. Give them as much room as possible. So if this is true, if we want the ball to bounce off here, but not anywhere up here, what is true about the y of the ball versus the y of the paddle? It's always, all right, now it's half the height this way and half the height this way. You see that? So it's going to be, this is the center of the ball, and this is the center of the paddle. If their y's are within this amount of each other, or any less, then we should bounce off. You see that? So so here's the paddle's y. Oh gosh, what do I want to say? We have the paddle's y. So that's this current y plus half of the paddle's height plus 60 plus half of the ball's height from here to here. That is 20. That would give us, boop, 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 this y coordinate. And we want the ball to be either exactly equal to that or smaller than it to be hitting the paddle. So the ball's y is either equal to it or smaller than that. So less than or equal to that to be hitting it. You see that? Any higher up, this will be false. And so we should let it go past the paddle. Any questions about that condition? Because a similar condition needs to be true for the bottom. All of these things, like this needs to be true and this needs to be true at the same time. We also have to say something about hitting the bottom, because otherwise, like if the ball's down here, both of these are still true. You see that? The ball's x is in the right spot, and the ball's y is definitely underneath this calculation. So we need another rule for when the ball is right here. That is the lowest that it could be in bounce off. All right? So that's going to be when, what do we want? We want the ball to bounce off the paddle when its y is at least here. Could be bigger. When the ball's y is equal to or greater than this spot. How do you get that spot, this y coordinate? That's equal to the paddle's y minus 60 minus 20, half the height of the ball. Paddle y minus 60 minus 20. And all three, like this is A, B, and C, if these are all true at the same time, then the ball is at the paddle. We need them all to be true at once. Let me try and show that to you. So if the ball is like right here, sure, it's within the y range. These will be true, but we don't want to bounce off yet because the x is not close enough to the paddle. If the ball is way down here or something, the x is within range, sure, but the y is not. The y is smaller than this. Smaller than paddle y minus 60 minus 20. That would have been here, but it's way down here. We still don't want to bounce off. So essentially with these three things, let's see if I can draw in green what it's trying to do. It's trying to make sure that the distance between the paddle and the ball and the x, like if this is true, is at most this. It's trying to make sure that the distance between the ball and the y, that distance is at most this. And then the distance between the ball and y is at most this. So it's like building a rectangle. It's like if the ball is anywhere, if the center of the ball is anywhere within this like green rectangle here, then it should be bouncing off the paddle, something like that. That's how I want you to think about it. But it is a bit complicated to determine all this. I'm just giving you the answer, but I hope you can kind of see where it's coming from. Are there any questions about that? So all those things, if they are true all at once, that means the ball is within the proper range and should be bouncing off the paddle. Anywhere else, we should just let it slide. Keep going. And if this is true, if the x's are small enough, if the y is small enough in this direction and small enough in this direction, it's like it's no higher than this and no lower than this. That's pretty much what it's saying. So like there's your range. No higher than this and no lower than this. That's what those two are saying right there. All right. So if all that's true, then we can bounce off the paddle. So I will not try to name this anything other than A, B, and C. So let's calculate all of these conditions. Like this is either true or false. This A, this B is either true or false. This C is either true or false. So ball X, is that less than or equal to paddle X plus 15 plus 20? B is, hey, is ball Y less than or equal to paddle Y plus 60 plus 20? C is, hey, is ball Y, I guess I can copy most of this. Is that greater than or equal to paddle Y minus 60 minus 20? It's the lowest end, and that's the upper end above it. And so those are all the ranges. So if all three of those things are true, if A is true and B is true and C is true all at once, then the ball is at the paddle. We should bounce off. What does it mean to bounce off? We got rid of all that in this function, bounce if hit wall. We said game over true, but it was like rein the ball back into the proper x coordinate, and then like bounce off. So change its x offset. So that was, let's say that this is the paddle, and like here's the ball coming into the paddle this way. We want it to bounce off this way. And what was the direction, the piece of the direction that we had to negate? It was like it was going a little bit to the left and then down, and we want it to go still down, but now to the right instead of to the left. So it was the x offset that we negate. All right, so bounce if hit paddle. So if all these things are true, we would like to make sure that the ball didn't go any farther than it should have. So like set the ball x to be exactly equal to this, like rein it back in if it tried to go inside of the paddle. Because if it's strictly less than, that means like the ball's trying to go like right here or something, like it moved too far in one frame. Make it come back out to be exactly hitting the paddle. That's the first thing. So exactly hitting the paddle is when the x's are lined up like this. And then bouncing off means change the ball's x offset so that we are bouncing off in the opposite direction. All right. And so I appear to be setting two global variables, ball x and ball x offset. And so I have to say that. Global ball x, oops. Oh gosh, what have I done? Global ball x. Global ball x offset. And so that's essentially what should happen if we hit the paddle. Calculate all these conditions. If they're all true at once, then the ball really did hit the paddle. Make sure it's exactly touching the paddle if it wasn't already, and then have it bounce off in the proper way, which is involves negating the x piece of the direction to make it bounce off to the right now, because it was coming in towards the left. And so, yeah, the draw frame now has a lot of stuff to do. It's like move the ball a little bit, see if it hit a wall, bounce it off, see if it hit the paddle and bounce off, and if it hit the paddle, do this. If it hit the paddle, bring it back in to touch the paddle and change its direction. So let's see if that did anything at all. Yeah. So we've got a ball. We've got, oh yeah, we've got bouncing off the paddle, yay. And so let's check that our tests are correct. Like, let's make sure that a tiny sliver of the ball touching can still bounce off. Yeah, it doesn't have to be exactly on it. This is what we wanted to check for. Let's do the same for the top. Can make the ball move faster too. It's like just a tiny sliver is all it takes. And then let's make sure we didn't mess up by like always making it bounce off. So let's make sure that we can still lose if we miss it. If we still miss it, yeah, good. So it looks like it's working. Any of that? There's a lot going on. So I'll try to explain it. Let's make the ball a little bit faster. We made the length of our hypotenuse 1. Let's make it like 2 times 2. Let's make the ball move twice as fast. Is that more of a better game? Yeah, it seems to be working. A funny quirk of the way that all this stuff is working with turtles is that if you hold in the down arrow or the up arrow to like move fast, it slows down the ball. So like that stops time somehow. But that is, it's beyond the scope of this class to fix that problem. But still seems to be working. Yay, so that's fun. Yeah. Does it make enough sense? Are there any questions about what's going on? It's so cool. It's very satisfying, I think. And then once we hit the left side, it's going to stop the game. I guess we could have had a better condition for that, but there it goes. All right, let's try and talk about what's going on here. As we did it. So, all right, how do we make all this happen? We had this draw rectangle function. We drew the bounding square. Looked like that. And that was the default turtle doing that, so we hid that turtle. So that was like at the very beginning. Draw our little square, make the turtle go away. Then we set up our paddle. We made a brand new turtle for the paddle, stretched it, colorized it, gave it a nice starting point. I guess you could give it a random starting point if you want to, but this is like good enough. Keep the x constant, but like the y can change and be up or down. And we're going to use these paddle x and paddle y variables to keep track of where the paddle turtle should be. And we'll always keep telling it to go to the new paddle x and paddle y as we change it. And it was this on key press stuff that was like calling these functions every time we press the up key. It was changing the paddle y, making sure we don't like hit the top, and like telling the actual paddle turtle to move. That's what those did. It's like I press the up arrow. It's going to tell the turtle to move up a little bit, 10 units at a time. And then finally we have the ball. The ball is another turtle on the screen, and we give it a shape. It apparently can still be a square just like the paddle. We're just going to stretch it evenly in each direction. And then we're going to give it a random starting point. Making sure that it's on the right half of the screen so that we don't immediately lose. Giving it a random direction by picking an x and y offset. And then we normalize that direction so it always moved regardless of which direction it picked randomly. It always moved at the same speed. And the speed used to be 1, but I just did this multiply by 2 to make it a little bit faster. So now the length of the direction hypotenuse, if you remember all the triangles that I drew, it's now 2 units wide, 2 units long. And so that makes it move that much, 2 units every frame. And then we make sure the ball starts out in its random spot, and we get it going. So moving the ball is this loop down here, way down here after all the functions. It is, well, we make sure that the game is not over to begin with, and as long as it's not over, we're going to draw a new frame, which involves moving the ball, nudging it slightly, getting it in its new spot. And so what does draw frame do? Well, it takes the ball and it manipulates it by its current offset and makes sure that that was okay to do. So maybe it went a little too far and it hit a wall. We should bounce off the wall if that's true, like change offsets, change locations. It may have also hit the paddle once we moved it, so we should bounce off the paddle as well if that ever happened. So after both of these, after this potential bouncing has been taken care of, then we have a potentially new value for ball x and ball y from this one. Either way, it's a new value, and we should make the ball go there. That's the new spot for it for this frame. All right, so hitting a wall is what we had before. It was check if anything's out of range. If it is, like rein it back in to be exactly touching the wall and make sure it's going to bounce off of it by changing the corresponding part of the offset. Though the left wall now don't bounce off, just end the game. Game over is true if we ever hit the left wall. but I guess we're going to keep the ball inside the bounds still. So that's that. And then bounce if hit paddle, we noticed there were a few conditions that kept track of what needs to be true about the ball in order to stay within the bounds. Like it's got to be, like the highest Y could be up here. The lowest Y is way down here. Like that is as far up and down as it could be, and then as far left and right as it could be is this much. So we kept track of that. And these three conditions, which better all be true at once, like make sure it's small enough to be hitting the paddle, make sure it's within the upper and lower range of the paddle. If they're all true, then if it ever tried to go past the paddle, bring it back in, and make sure it's going to bounce off for the next frame. All right, so that's bounce if hit paddle. And now, like that might have changed ball X, for example, and the ball X offset. Bounce if hit wall might have changed, again, ball X and ball X offset, or Y and Y offset. So something has changed after we call these functions potentially. We have a new value, no matter what, to go to, and that is our new spot for that frame. And we just keep on doing that as long as the game is not over, forever and ever. And that gives us beautiful Pong. Any questions about that? Is it just too complicated to wrap your mind around? All right, definitely study this code. It's going to be fun to get right, I promise. But yeah, that's really all that I wanted to talk about today. I just wanted to do Pong so that we have it and you know how to make it for real. So the last piece of today is I want to talk about your next programming assignment, which is exactly what we just did. So this is your last programming assignment in the class. It's going to be due the 12th, which is next Friday. That's the last week of class, last day of classes technically. Your last programming assignment is to do exactly what I just did. So please implement Pong by following all my steps, and you can change it as much as you want, of course. Maybe you can make the ball a circle rather than a square. Make it cool. Make it like change color as it hits something, but you don't have to. But here is all you got to do. So take what I did, recreate it, and upload a video. Explain to me that you didn't just type out my code. Please explain that you understand at least a piece of it, and show me it working. So that is what I want to see. I want to see you doing this, and that is that. So that will be your last programming assignment in the class. And because you're implementing what I just did, I will not be giving you the code that I wrote today. You're just going to have to watch the video if you want to see it again. Okay? So that is, I think, all that I have if there are no questions. Time to go write Pong yourself.